Hey, this is the next Modern OpenGL tutorial. This one is about C++ shader programming, getting started, you voted for it. I created a simple OpenGL C++ template project with a GL window that I already showed in the previous part. Then we have a mesh class. To that we can add 3D vertices, and these are passed then to an OpenGL vertex buffer and vertex array. And finally to shaders in the rendering pipeline, where they are, for example, positioned by the vertex shader or colored by the fragment shader. But before I can explain this in detail, let me give you an overview of the C++ project. Here we have it, it's Visual Studio 2019, and here in the main function we create an instance, a unique pointer of the GL window class, and give it a size and a title. Then the GLFW window internally and glue is initialized, and this GL window has two members, an OpenGL render context and a mesh. Both are classes that I created. First, let's have a look at the render context. At the moment this is a very simple class. It has a pre-render, a render and a post-render method, and that I just clear the viewport in a certain color, and in the render method I bind the vertex array and the vertex buffer, and then I draw the triangles of the mesh. For drawing we need the vertex count from the buffer that we get from the mesh. You will see this in a moment when I show how the mesh class is structured. Later on we will also have an index buffer, and then we can use draw elements instead of draw arrays, but this is an optimization that I will show in one of the next parts. Okay, so let's jump to the mesh class. It is also not too complicated. As you know, it holds a list of vertices. For these I created a class called Vertex 3D. A vertex can have many attributes like the position, the normals or texture coordinates, but for this first part we are focusing on the position in 3D space, x, y and z. Okay, now let's come to the OpenGL vertex buffer and vertex array. For this I implemented a wrapper class called OpenGL vertex buffer. It has two member variables to store the address to the vertex array and the vertex buffer object, and both are created in the create method. As a parameter the vertices are passed. In our case they come from the mesh object. Then the vertex buffer object is created. To that the vertices are stored. Then we create the vertex array and connect it to the vertex buffer. Then we use both objects, which is necessary before we enable a certain attribute, which is in our case the position of the vertex 3D. And we also define the format. This means we tell OpenGL how the layout of the vertex array looks like. We have methods to bind and unbind the vertex array, and we have to bind it before we draw. You remember, here we have the render method of the render context. We bind the buffers. This calls bind of the vertex array class, and then we can draw the triangles. Okay, that's nice, but now let me show you where shaders come into play. When we are drawing, the vertices are passed to the OpenGL render pipeline. This is on your graphic card, and there are two programs running, the vertex shader and the fragment shader. These are compiled programs. To that we can pass input parameters. Let's have a look at the most simple vertex shader that we are going to use now. By using the vertex array with the first index, we are writing the vertices for the position attribute to the shader. To set the position for a vertex, this attribute is assigned then to a default output called GL position. And here's the corresponding C++ code that enables this position attribute of the vertex array and defines its layout. Okay, now let's see how to load and use the shaders. Here's my shader class, an extended version of the one that I used in my previous shader beginner tutorial. It has a load method to load the vertex and fragment shaders, then a use method to use the shader, and then we have some setter methods to pass values to the shader. I will go more into detail for that later on. Okay, so I go to the mesh class because there I want to use the shader. I will include and then add a member to the mesh class of type shader. That's a shared pointer. I will create it here in the constructor. And then I go ahead and load the vertex and a fragment shader. I will explain the fragment shader in a minute. Okay, and then we can use it in the bindBuffer method that is called before we draw the mesh. Using the shader means that our loaded and compiled shaders are used now in the rendering pipeline to which the vertices are passed. Okay, so let me show you again the shaders. This is the vertex shader. For that we set the position for each vertex in 3D space. And this is the fragment shader. For that we are going to set the color. It is defined as a so-called uniform, which is a kind of variable of the shader that you can set in your C++ code. You will see in a second how to do that. Let's start the program and see what happens. Again, we have the triangle, same position, but it is black. Now we use our shaders, it is not the default pipeline anymore. The color of the fragment shader, this uniform, is not set and therefore it is black. Let's have a look at the shader. It has an out value to define the color of the fragments, which are, in the end, pixels on the screen. But it is black because we don't pass the color in our C++ code to the shader. So let's do that. As I said, our shader class has setter methods that we can use to set values for the uniforms. So do this now for the color. As we saw, it is a 3-component vector. And the name is color. I use a red tone. That is passed then to the color uniform and then finally to the frag color output in the fragment shader. Let's have a look at the implementation so that you see what is going on there. First I get the location, the index of this uniform by name, and then I use this location to set the value for this uniform. Okay, and that's it. We can start now, and as you can see, the triangle is red. Okay, that's nice, but now let me show you how to use the vertex shader to dynamically change the location of the mesh. What I'm going to do is to add a new uniform, and this will be a matrix. Because when we are multiplying this position with a translation matrix, then we can move the vertices around. The mathematical topic behind that is linear algebra. If you're interested in that, let me know. It's a huge topic, but it is understandable and we can do a tutorial if you like. For now, just accept that this is changing the position, and now we'll show you how to pass a translation matrix to the shader. We are lucky because the GLM library has a matrix with 4 components called mat4, and I added here just for demonstration as a member to the mesh class. Then we need a method to set an offset. For this I use the type vec3. Then I initialize it to so-called identity matrix. If you're not familiar with this term, this is a matrix that has all zeros except for one set along the diagonal from the upper left to the lower right. Again, you don't have to understand that now. Just keep in mind that multiplying with the identity matrix will have no effect on the position of the vertices. But we are going to implement the setOffset method, in which we are going to use the method translate of the GLM library to add an offset to this matrix. Okay, nice. Now the only thing we have to do now is to set the translate uniform to this matrix. For this I use the method setMat4. The name of the uniform is translate. Okay, now the only thing that is left is the user input, and for this I prepared a handle input method in which I check if the keys WASD are pressed. Because with these I want to move around my triangle, so I define a constant value for the offset, and then I use this to set the offset for the mesh for the different directions. Okay, you see that's pretty simple code. Now we can start it, and then we can use the WASD keys to move around the triangle. Okay, that was it for getting started with C++ OpenGL shader programming. I have an OpenGL template project here on my GitLab that we will use as a base project for all upcoming OpenGL tutorials. You can clone or just download it and then compile. It contains a Visual Studio 2019 solution, and all the libs like GLM, glue and glfw window are included. If you join here as a member on Jayanam, you get access to all my private repositories on GitLab, and the same perks you get as my patron. The minimum to get access to my private repos is the Golden Card membership, but of course you can also become a Ruby member. So I hope you liked this tutorial. If you do, then don't forget to subscribe if you haven't already. If you have any questions, add these to the comments below. Again, join as a member to get the supporter role on my Discord to ask me anything. Also follow me on my Instagram, Twitter and Facebook, and I see you in the next one here.